Start streaming. I hit start streaming and I'm on the standby screen. It's this one. Streaming. I hit start streaming and I'm on the standby screen. It's this one. My voice is coming through. Oh, can you hear me? There we go. Everyone hear me? Fiddle with the sound, but I'm not sure I got everything adjusted correctly. Not sure why it played the music over. Strange. Woo! Anyway, hello. My name is Mike Crossmire. I'm the VFX guy here at City State. I'd like to say I make twinkles. Anyway, what I'd like to do today is do a little explanation, demonstration of how our particle system works, just so people kind of understand where the effects in our game are coming from and know a little bit more about how they're made and why things may look the way. I'm trying to keep an eye on the chat at the same time. See if I can answer questions on the fly, but anyway, what I'm going to do is I'm pretty much going to wing it. I have an idea about what I'm going to talk about and to show you a few things and maybe show you the construction process for making effects and informative. May even show something that you like. The thing I would like to point out at the very beginning is that we are making this game not Unchained hard mode, meaning that we are developing all of our own tools, and so the editor is not always the most cooperative. The reason for that is that engineers are busy working on many of the more important core features of our game, performance, and really important stuff, the networking, basic gameplay things, and so the editor is not quite as polished and but it's still very functional and gets the job done. So let's start. See my screen. I also have a magnifier which I will call up because I have a lot of text entry. Let's see. Anyway, so I am now in the particle editor. This is a list of effects that I've made. I'll show you. Back to that one later. Anyway, here is the particle editing environment. As you can see, I've got some swords and other doodads that are in the scene right now. Mainly so I can make an effect and then offset it and then line it up with that item just for testing purposes. It's an easier way of doing it. You make effects in the editor, they always start at the origin. So origin is actually somewhere in the middle. This box that you see on your screen is actually at -1 in Z, so that effects I make don't clip this artificial floor. Just a box floating in the nothingness. X created starting here. I have an axis in the scene, so you can get an idea of what the basic world are. So we have X, red, Y, green, Z, is up. Again, the origin is actually about right. Yes, doodad is a technical term. So is thingable. Anyway, so what we have for our effects is a particle system. Now, that means that all effects in our game compose entirely of particles, which are, I'm sure most of you have played a lot of video games. Particles are the most commonly used thing effects with. Anyway, so what our system has is it has two main things for particles. It has a spawner, which are shown in spawners, determine where particles begin their existence in the world. I hope you can see it up the magnifier. Monitor is 14. It needs to be pretty big because I've got a lot of information I need to see on it. Anyway, so here are a list of parameters that concern spawners. So there's color, brightness, opacity, width, height, size, rotation, and we have things like radius, their measurements for where they begin. Our particle system operates in two different coordinate systems. So what that means is we have polar coordinates, which are based off of a spherical space, and I'll show you a little diagram. Provided so far ahead of time. That looks like this. So origin is at the center of the sphere right here. Measure two ways. We have a radius out from the center. We have a measure on an axis that's theta. That goes this direction, and the yellow shaded area here we have phi, which goes the other direction. That's seen in purple on this little diagram. So the phi value is like longitude. So when you're measuring longitude on a globe, phi of 0 is at the north, 90 is at the equator, the south pole. Likewise, measuring theta, 0 here, right, 0 is actually here. We have -90 plus 90. It doesn't really matter actually because you can measure it from 0 to 60, or I can actually give it. It's usually ideal with negative and positive coordinates because it's easy. It's like conical shapes because you do something like minus 30 degrees and then plus 30 degrees. Sweeps out a column. Anyway, and then we also have the ability to define space in Cartesian coordinates, which is used to high school geometry, x, y, z, so rectangular space. So anyway, hope you're still here. Right, I have a habit of not speaking very loudly, so my voice trails off and the mic doesn't quite pick up. Just tell me. I tried to adjust the mic so that bump up the volume a little bit so I don't have to speak so loudly as to annoy people. Anyway, okay, so back to the spawner. So we have got a spawner, and that will define where a particle is its life. So say, for instance, then we want to add a particle is actually the thing which displays. So that would be the actual item that you see in, like, where the twinkle, bit of fire, the wavy bit of energy, whatever it is. I will just add a default one. It'll be so you can see how. Now, if I want to generate some particles, what I first do is go to the spawner, and then let's say start off with spherical. It's the polar. So what I want to do is I want particles to spawn fixed radius from my origin. So what I will do is say, let's make it, but I want them to appear ring around that point. So then what I do is turn on magnify. I go to spawn theta. So I can do this. That creates a random value between negative 180 and 180, as I was talking about. Now what I need to do is make this particle actually show something. Because by default, it's showing sprite number 0, which happens to be blank. That is a good segue for showing you how the sprites work. So fire off. It's a little tricky because magnifying. Trying to screen. Fire up. Shot. It's a little tricky. Playing with my other monitor right now. Actually, I'm just going to do this. So, all sprites in our game, which are used by the particle system, all live on one giant texture sheet. At the moment, this sheet is 4096 by 4096 pixels. They're all divided equally into cells, which are 8 pixels on a side each size. So everything It's kind of low res. It depends on what the actual thing is supposed to be. So in some cases, 120 pixels is perfect. In some cases, it's actually a bit too much. It's kind of a waste. Like snowflake down here, which doesn't really need to be quite that detailed. And in some cases, it's a bit too low, since these shield effects here. But what I try to do is fudge a bit, things a little blurrier, render nicer. One unfortunate side effect of dealing with video games is that you must deal with compressed textures. So this is a beautiful 32-bit target image right now, which is perfectly rendered, but when it gets compressed down to DPS format, it does gain artifacts and doesn't look nearly as pretty, especially when dealing with things like glows and things which have very soft edges. You really see problems. But it's one of those things you have to keep tweaking and tweaking, adjusting. Um, it's a little bit fiddly, but best I can. So anyway, back to now I'm rendering sprite number 0, which was actually blank. I leave it blank. This is the default. I don't want spamming particles at me. And we will try number 6, which should be easy ball. First thing we need not loop. Spawn rate is 1 per second. Now, the way our system works is that when I edit something, I actually do not see the result of what my edit was instantaneously. When I edit, actually, it's processed as soon as I click off of it, notifies the build server. And my data that I'm working on is sent to the build server. It builds, see from this build console down here, and then it comes back to me and it tells the client, which is running here, that it's updated, and then it updates my display. Hit refresh view. Now, fortunately, I have some stuff that's kind of in the way, but what I forgot to do was I forgot to set feet. So I'm doing random values between -1 and 8 around the equator. Now if I set phi to 90, that will make it here on the surface of the sphere at the equator. What it's doing now is it's actually all of the particles at the very north. So it doesn't matter what theta is, they're all going to be. To move away from the North Pole toward the equator, the size of the circle actually is. So it's now generating particles randomly surface plane. Bump this up so that it's silly that. Server. And I will warn everyone again that occasionally we get weird things that happen when I build something that doesn't quite like, or it comes back in a strange state and error messages pop up, and sometimes the editor crashes, but it's being worked on. For the most part, it works pretty well. It's gotten us this far. As soon as engineers have more time to devote to this area, some nubbins, and this will start to work. So now I've got fuzzy ball generating 90 of them per second. Sure. Be able to see well enough when I click in the text fields, and most people don't play their streams back stupid high resolutions. See, spawn feeds at 90, spawn rate is also at 90. That's measured in particles per second. Now, if I wanted to put them on the surface of the sphere, I could do the same thing. And this particle, small. They have a very soft edge, and they're all overlapping it. It's a big. My guess is that I'm not going to be able to cover a whole lot of stuff in this one stream. I really wanted to just give a basic overview of how the system works. Try to explain why the effects we have look the way they do. Effect system is very rudimentary in some ways, but in other ways it is quite powerful. Like most other particle systems don't have these polar coordinates. And even if they seem kind of obtuse at the beginning, actually extremely powerful because I can do lots of interesting things. The reason for that is because I make a particle system like this. I have a spawner particle. Now these can actually spawn more particles of their own, so I can do lots of interesting things. For instance, show you something which is more complex, which may or may not be used in an effect in a balancing act, because adding more particles is the main tool I have, but you have so many effect performance adversely. So what I've done actually demonstration power of the ring. In this case, I have a center point, center of this dome, which would be maybe where the player is, and it generates particles that are 1.2 meters away. What that does is that generates a particle which is not actually rendered. What it was, I just left it at sprite number 0, which is blank. I could also set its size to 0, so, which would accomplish the same thing. This makes it not show anything visually. One concern in particles is overdraw, where you have lots of things overlapping on the screen. That taxes video cards, GPU, just has to do a lot more calculating. Overlapping, especially at alpha objects where you have something semi-transparent. So what that does is that actually creates a point in the center of these rings. Randomly, it creates those points. Those points generate rings much like the other example earlier, where it just generates in a circle. Center axis picks a random angle, so it creates this kind of dome look, but I don't have it go all the way around in 60 degrees. So I don't have it go. This phi setting, I have it go 10 degrees to 110. So go somewhere up here, kind of toward the top of the dome. It doesn't have to go all the way to 0. It sweeps down here. So if we're on your player in the game, it wouldn't slip through the ground too much. Let's go back to our simple. I have a couple things I can control on a particular particle sprite. Mainly, I would adjust over time values that describe its color, which are on 3 different channels: brightness value and an opacity value. Now, the color works is interesting because you may be familiar with the way some of the art tools work, and those generally, when they have a color picker, are on a scale of 0 to 255 because 4-bit color. So it's 3 channels, red, green, and bits. The way ours works is it's on the floating point. So values all go from 0 to 1. So, for instance, if I wanted to make this glow ball here yellowish color, I would red at 1, have green value about half of that, blue at 0. There is one caveat: our particle system is not color adjusted correctly to the way the rest of our game is right now. So recently added support for different color space. It's difficult for me to describe exactly quickly, but anyway, the colors are a bit shifted, so they're not quite what you would expect. So theoretically, if I did red 1 and 5, I should get an orange color, but they're shifted a bit more to yellow. As soon as some adjustments are made, the colors in the particle system will reflect that as well. Those of you who are testers, you may have noticed that like the fire and some of the other things in the game look a lot paler than they used to. That's because they are still using lighting on the particles adjusted. So anyway, if I really want this to look strange, what I have to do is budget for about half of that. See, there's a lot of typing. Everything is done numerically. Actually, this is something I sort of asked for. We were originally going to do a complicated system with a graph, back to something fancier in the future, but now what I wanted was something that was simple. Programmers could use or develop more quickly. The system we have here is actually not far removed from the original particle system Eggs wrote. Very, very short amount of Kickstarter. I cannot emphasize The fact that he came up with this whole thing just like a matter of like a couple days. Originally, what I did it was during Kickstarter, I had to edit a text file in JSON, which some of you JavaScript notation that described all these parameters. So later, created the editor. They basically took those and they just made them a lot easier to edit just by entering in values like this. One nice thing about having fields and doing this textually is that our ability system is quite complicated. Eventually, it will be nice to be able to pass it parameters and other things, and it's a little bit like a little more toward the code side, so it might be easier to implement. I can just like enter an expression in to describe changes. Our particle system now is not terribly dull. They kind of play the way they play, and it's much more control. So, all right, let's say I want to actually animate dots or the dots. I wanted to make shift time, so start with 5. Do is I can adjust over time. At the moment, there is a life setting which says how long it stays displaying. Say life, max life, 30. That is measured in frames, which are 1/30th of a second. So this collection of dots, each dot lives for 1 second. Vary that, I could say some of them 12, 30, and out faster than that. Shift them over time. Shift 30. So now I want them all to go stay. So enter in some keyframe values like this. What happens is that time in our particle system is always relative to the lifetime of other particles or spawner above it. So in this case, I have a spawner which is generating 90 particles per second. Each of these lives up to 1 second. So I want to keep the value. I create an array like so. And that divides time into segments because of values. So time, it will start 0, during the last quarter of its life, which is pure green value, which control its orangeness. We want that to go away, so we want 5. Then that will genus from it. Likewise, we want to get this. That. Unforgiving. If you type in something parse correctly, it blanks it out on you. Type it. Now, see that each of those dots will start out its life, and about halfway through, it shifts to blue. That. So, a lot of typing. Thing I've had to learn is how to mentally calculate what color things are just typing in RGB. So once you understand color theory, it's really not too bad. Just red and green, yellow, and that the closer the third value is to the first two, less saturated. Yeah, ray of shield. So let me show you one of made this actually illustrate the problem with the colors, but it'll be a good demonstration of brightness works. So in addition to the color values, I've got other two parameters here, color, brightness and opacity. Now brightness is pretty obvious. So as you can see, bright yellow circles should be orange again. Shift. What the brightness does is exactly what you think, but how that combines with the opacity creates different effects. So the trick is to remember that when brightness and opacity are equal values, then the particles blend values behind it on the screen. Pure blend. The color mixes nicely with what's behind it. So yellow object in front of which is blue, like this. See, fuzzy edge. Expect. Look at something very bright behind it. See how still make out that these are yes yellow circles. What Andrew did was his system ratio between brightness and opacity is how additive things are. Additive blending is very useful for energetic things like fire, lasers, and so forth. So, for instance, if I make opacity slightly lower, brightness, so now look at these yellow blobs. You can see how they start to meld together more. As they overlap more and more, they go to white. It's not too bad right now. They're a pleasant blend. Look interesting. That's because I've only made the opacity 0.6. Likewise, I can actually crank up the brightness to a value that's greater, which comes in very handy because in some cases I can tint things, say in orange. I can start with a gray image and I can tint it orange, but I can crank the brightness up to some stupid value, like 4 or 5, and begin to create the effect that you see like in like a black body simulation where brights almost white, but darker values still visible. Get some interesting effects to create very bright, energetic looking things from source images. Now, it's down to 2 on opacity. See that now it's blending, but it's still a yellow blob in front of the bright sky. As the value gets more towards 0, because the ratio is now very bright. It's headed way more. So anyway, that's how that works. And the nice thing is that it can do both of them in one effect. So over time, I can actually make something more additive, less additive over time. It's very handy, like fire transitioning to smoke, other effects. Probably were wondering why our Sprite sheet is so huge and everything's on one sheet. Everything is done that way. The reason is for performance. Game is very dependent, and one of our core features of our game is support for battles, and so our game needs to be as ultra performant as possible. And what this particle system allows us to do is that all particles that you are seeing on the screen, seen without playing, all be rendered at the same time. So there is the one unified material which renders all of them. This is a very important feature. Now, the way particles work now is somewhat limited because color, brightness, opacity, and animations is pretty limiting. So much can be done that looks very fancy that way. Our game is nowhere near as sophisticated as a lot of video games out there right now, but it is being worked on. As soon as players have more time, I have an extensive list of features that I would like added to our system that will be. Anyway, I just thought you should know that that's why our system works the way it does this time. Anyway, so show you something which is a little easier, which uses turn on this extract. Oh, here's test. Quite a bit of fire. Fire that's in our game. A. But honest, but I can't. I'm not telling myself. It's because I've talked about for features we'll be getting in the future. So the goal right now is to make this look as good as possible. This is a demonstration of a sophisticated system where one particle is generating more particles beneath. So, like the other one, we've got a base system which is generating particles in random arc like this, shoots the particles out, then the flame particles are sprites on the sprite sheet. They are the color over here, so that they go from an orangey color and shift in slightly. Brightness, see it goes from 0 to 2, 5. So base sprite that I'm actually using is fire. The reason I did that was for the sake of flexibility. Since I have a limited amount of space, doing flipbooks, 1,020 cells become used up rather quickly because that's the only way to animate things. Pretty efficient, or try to think of this. That's what I've got. So flame particles are actually these blobs right here. They're somewhat flame, but as you can see, they are absolutely gray. So they're tinted G color, like so. I was explaining before, I just crank up the brightness value. That gives them a much more. The way it works is that fire particles live for a while, then at some point randomly generate small smoke. So see, smoke puff was a little more complicated for the color values I wanted to have them fade away in kind of a subtle way. So the only way I can slice up time into smaller increments is that I have to add more values to the array. So that's why these all have a lot of values in them, so that I have better control over the time. So you can see these actually split up into 8 parts, and that allows me to shift the color very early in its life, adjust it gradually. Size of the smoke particles animate so that they go smaller to larger, like so. Particles also move. Interesting thing about system work is that other particle systems, a lot of times the spawner particles are separate things entirely. In our system, relationship is a little more ambiguous. So create a spawner. Other systems, like I've used Gamebryo, I've also done some. When you create particles, the speed that you set for particles moving is set within the spawner itself. So you would define cone shape, and that set the beginning speed of the particle right there. Actual particles themselves are more concerned with how they look. Our system, the spawner, as I mentioned, says where they begin their life. Motion actually controlled the particle itself. So these flame fans, the orangey bits here, have to be set to move. What I did there was I set the velocity radius. So spew out pattern, start at random value between 4 to 6 meters per second. All of our measurements are in meters. This example seen here, divided up so that each grid square is 1 meter. Then, over its life, about halfway through, picks another random, down from 2 to 4. So flame particles slow down a bit just before. One other thing is we also have the concept of elevation. Not only do we have x, y, and z coordinates, but there's a special coordinate which is elevation. That is always space up and down. So no matter which way the particle is headed, elevation always represents a value that is straight up and down. This allows me to fake things with gravity. Our particle systems don't actually have physics in them. That is something I would like in the future. There are no physics, no deflectors. So what I do when I want to approximate ballistic motion, gravity, is that I just have to keep. So in this case, the flame particles actually rise up a little bit. So they go from 0.2 to 0.7 to 0. So they rise up a bit. Show you it's exaggerated. So see how it's Let's do fiddling yesterday. This will probably be used for some kind of burst heal effect. I have not tinted it. As you can see, it spits out a particle, and those actually leave trails. What I did here was, whenever we want to have a system which does something one time, the way that I get around that, we have some one-shot effects we have in our where it needs to be a controlled burst. So what I do is I create a root object like this at the very beginning, and then that spawns a particle which does not render, but has a time associated with it. That does allows me to then put another spawner which will actually spray out the color pattern. Because the spray is dependent on the lifetime of this axis here. Create spawn it's kind of more like a garden hose or something that's more like you're pulling your trigger down, controlled burst for however long. In this case, controlled burst is between 9 and 12 frames, so less than half a second. That sprays out a bunch of bright glowy dots, which are these head dots here. Those leave a trail of smaller dots. Dots that it uses as a trail actually don't have velocity elevation on them. What they do is they inherit value from the head. This is another nice feature. Parent particle which generates child particles. Child particles can inherit some of the velocity. That's really useful for tails behind things and get lots of different effects based on how rigidly the system inherits velocity from it. So, say I wanted to make the particles dots actually fall, not be quite so fluffy. So on the dots, velocity elevation over time, and I can fake kind of a real gravity by saying start at 0, they go to -1 meter per second, -2, doubling that, and -4. So, build. Still get. Wish that got some kind of little green light or something back here that told me when it's actually going to be to display. There we go. So now, see that twinkles kind of fall more like sand behind. That's probably a little bit too much. Dots last a long time. Last anywhere from 12 frames to 60, so they could last up to 2 seconds. Learning to type in all the numbers and doing it this way is interesting. Fortunately, I'm technically minded, so it's not really so bad. Most of the other editors I'm used to are more about entering in or dealing with dials and editing curves and things like that, and eventually it would be nice to have a curve color picker, so I didn't actually have entering color values. My floating point 0 to 1, but so anyway, so now the particles don't last quite as long. I didn't want quite so gravity, effective gravity. Just do I did. I adjusted the velocity elevation value to be a lot less. It still doubles over time, but kind of simulates a gravity, but makes it look a lot more floaty. Good news is that we still have a lot of stuff we can cover in future streams, I hope, but some interesting things that I'd like to show off. I will explain again basically why things look the way. Here's some of this. Here's one from the game. Let's see. Show you. Let's look for fireball. Fire liquid ball. I have to be attentive when stuff, so catch everything. Now again, this isn't the greatest effect on me, but it shows how it works. I've got a sprite sheet which has this ball I made in Max. Just use flame points in the game. Fireball. Oh yeah, Tyler's saying I need to show you the text amendment. Here's it's even fancier. This really shows off again more the power of the polar coordinates and what you. This is entirely made just with these camera-facing particles, which are kind of this smoky ring. The way it does it is it creates those kind of null points in a circle. Each of those generates a bunch of particles that come out from it by fiddling with that velocity parent that I was talking about. It creates the bending effect because as the root of the arms moves around, I have them rotating both theta axis, so that kind of gives it that weight. Because of the way the parent velocity works. Ones that are close to the beginning of the root inherit more of the parent velocity, ones that are toward the tip or less, and so they kind of lag behind. And this is an effect which is extremely difficult to do in other particle systems. Just out of the box, you have to some sort of big something in the arms, something like that. So in that way, this system is much more powerful. Anyway, I seem to have burned up my hour. Like I said, though, plenty of stuff to cover in future streams because a lot of other things, some interest. I do have a thread that's on our backers forum. It's just the title of it concerning spell effects, and so that's kind of an active thread going on about how the system works, my philosophy on the way effects in our game should be presented, and other technical things. So I would encourage anyone who has other technical questions or like that to put there. I try to answer at least sometime during the day. Thank you all for joining this hour, and I hope to be back on sometime again. Explanation and presentation, and be able to show you some new stuff that I'm working on. Someone screamed lunch, so that means I have to go to lunch. Editor closed. Thank you.